Alright, so this is parallel lines and transversals notes. An extension of the stuff that we did last week, Thursday, Friday, with the angle relationships. First term, transversal. You've defined it already before in your dictionary. I'm going to explain to you what it means. A transversal is a line that intersects two or more lines. In this situation up here, you have two lines going in the general same direction, L and M. They're not parallel, but they're going in the same direction. You have a third line that comes in between and cuts those two lines. This line is called a transversal. The line T in this situation would be a transversal. So over here, an example, that's what we're going to write, line T. Line T would be the transversal that cuts through line L and M. When you have a transversal cutting through a pair of lines, or two or more lines, it creates different angle relationships that y'all about to learn now. You need to pay attention so you can catch these. So moving down, angles formed by transversals. You have 4 different types. Duck your head, Aiden. Need you again. I forgot to say a little disclaimer before I started. So we got these angle pairs here, and we're gonna color code them. Let me see, pick whatever colors you want, just to make sure they're in different colors so you can identify. First one is corresponding angles. Reading to you corresponding angles first. Corresponding angles are angles on the same side of the transversal and in the same position. So in this case here, you got line L and M, and then you got transversal T coming through and splitting those two lines. It creates 4 different, it creates 8 different angles here. These angles have relationships. The first one is a corresponding angle relationship. I'm going to mark a pair of corresponding angles for you. A pair of corresponding angles would be angle 1 and angle 5. And I'm going to write those out to the side for you here too. Angle 1 and angle 5 would be a pair of corresponding angles. That's the only pair I'm going to mark on the figure, just so my figure won't get all marked up with different colors, a whole bunch of different colors. But there are more corresponding angles. For example, another pair of corresponding angles would be angle 2 and angle 6. Isaiah, name another pair of corresponding angles for me based on what I just told you. Thank you. Thank you for your honesty, sir. Now pay attention, please. Juan, can you name another pair of corresponding angles based on what we just talked about? Okay. This is not good for video. Faith? You got a question? No. Yeah. It's on different sides of the transversal. Read the definition again. Angles in the same side of the transversal. Transversal is line T in this situation. And in the same position. Faith. Angle 4 and 8. We already got 1 and 5, buddy. It's the first thing we marked. Yes. Angle 3 and angle 7. Thank you, Mike. All 4 of those are the 4 pair of corresponding angles in this situation you have over here to your left of this diagram. 1 and 5, 2 and 6, 4 and 8, 3 and 7. Alternate interior angles next. Alternate interior angles. These are interior angles, non-adjacent. Interior angles, non-adjacent, and on the opposite sides of the transversal. It's all in the word. Interior, when y'all hear the word interior, what do y'all think? Inside. You should think inside. You should ask yourself, inside what? They're talking about inside the two lines that are running in a similar direction. Like inside of L and M, you only got 4 angles options. 3, 4, 5, and 6. And then they get more specific when they tell you alternate interior. Alternate meaning they're on opposite sides of the transversal. And then they're non-adjacent. So inside and on opposite sides of the transversal. Non-adjacent. Alternate interior angles in this case would be angle 4 and angle 6. Alternate interior angles. So here angle 4 and angle 6. One, you got a chance to redeem yourself. What's the other pair of alternate interior angles? Angle 3 and angle 5. That is the other pair of alternate interior angles. Don't get that confused with like, so mind it in, you didn't even ask this question, but I'm going to just throw it out there. 3 and 4 are not alternate interior angles. They're on opposite sides of the transversal, but they're adjacent. That don't make, and they're interior, but they're adjacent. It's non-adjacent interior angles on opposite sides of the transversal. Angle 4 and 6 will be alternate interior. 3 and 5 alternate interior. So that we did. I did that one in green. My next one, alternate exterior. It's all in the words. Exterior meaning what? Outside. Good example of these. Well, let me read the definition. Exterior angles non-adjacent on the opposite sides of the transversal. Alternate exterior angles will be 2 and 6. 2 and 8. Excuse me. Angle 2 and 8. Angle 2 and angle 8. Alternate exterior. Reese, give me the other pair of alternate exterior angles, please.
Oh, 1 and 7.
Angle 1 and angle 7. Those are examples of alternate exterior angles. The last new angle pair I talk about is consecutive interior angles. Before we even go into this one, on top of consecutive, write this word for me. Well, it's not even one word, it's 2 words. Same side interior angles. Consecutive interior angles, that's the word you'll most see. But sometimes they call these same side interior angles as well. They both mean the same thing. Honestly, a lot of times it just depends on what textbook you're looking at or who decided to write the question. They flip back and forth between these 2 words, but they both mean the same thing. Same side interior and consecutive interior, either one of those that you see mean the same. Interior angles that are on the same side of the transversal. These are interior angles that are on the same side of the transversal. Consecutive interior or same side interior angles. An example of this will be angle 3 and angle 6. Angle 3 and angle 6 will be consecutive interior or same side interior angles. Irvin, what would the other pair be? I can't hear you, man. Go ahead, Kevin Rose.
4 and 5.
angle 4, and angle 5. That would be the other pair of consecutive interior angles. Alright, keeping that in mind. So those are those angle relationships I need y'all to start remembering. You already know some from Friday. You need to add these into your repertoire too. So don't forget the ones from Thursday and Friday. Vertical angles, complementary, supplementary, and linear pair. Honestly, 3 of those going to keep popping up today. We're going to be talking about those as well too. They still matter in this situation. These are just new ones that you're learning based off of transversals coming through. Cutting some lines. So we're going to do example 1. We're going to do this together. But before we do it, I need to talk about this figure. It's a little bit different than the one up top. Same situation though. So let me zoom in a little bit. This is all based off your perspective. In this case, instead of having just 2 lines going in one direction and 1 transversal cutting through, you got 2 lines going in a direction and then 2 transversals going through, depending on which way you look at it. So, for example, if you see C and D as your 2 lines going in the same direction, then you'll see your 2 transversals as A and B. You have 2 different transversals here. You got a set of angles on this one that have angle pair relationships. Then you got a set of angles on this one that have angle pair relationships. But that's just if you're looking at it that way. If you turn it one and looking at it from another perspective, from the side perspective, then A and B are your 2 lines going in a similar direction, and then your transversals would be D and C, and then you have angle relationships going this way and angle relationships going this way. This one's all based off your perspective. You got to be able to look at it both ways and determine angles. Important piece of information down here. I forgot to read this at the beginning last time. We still figured it out. Important piece of information. Angles must belong to the same transversal to be an angle pair. If they don't even belong to the same transversal, then they're not an angle pair. Alright. Business as usual. Make sure you tight though. Don't want to get your phone taken. Alright, so angles that aren't on the same transversal, they won't form an angle pair. For that, we'll just write no angle relationship. That'll be our excuse. So I'm making my way around. Let's see what you know. See if you paid attention at all. Aiden, start us out. A, angle 5 and angle 13. Tell me that angle relationship. Good. Corresponding angles. Oh, I ain't mean to write the word angles. I'm not writing angles no more. Just write that first part. We got next. Lucas, angle 7 and angle 14. Say it again. That's not it. Somebody else want to help him out. Reese. What kind? Alternate interior angles. Like I said, it's going to be based off your perspective. For 7 and 14, you're looking at this transversal B. So you'll be looking at this, and then those will be inside. Oh, angle 3 and angle 6. Ryan. Say it again. No. Mike. Alternate exterior. Good, Mike. Let me show you how you should have been looking at this though, alright? Turn this way. 3 and 6. If you look at it this way, you should see them as alternate exterior angles. Then after that, Chris next, angle 9 and angle 16. Yeah, you're right. I'm sorry, I paused for a second. Alternate exterior. Corner. Angle 4 and angle 7. You guessing or you telling me? Alright, consecutive interior. Also known as, in parentheses, same side. My bad. Miss Johnson, angle 2 and angle 10. Good. Corresponding. Caleb, let's see if you've been paying attention. Angle 8 and angle 14. Not bad. Consecutive interior. Or once again, same side. I'm going to keep saying both. I'm spelling consecutive wrong. I'm going to keep saying both because you need to know both anyway. I don't know which one they'll use. They bounce back and forth. Consecutive interior, same side. Imani, angle 6 and angle 11. How you figure that? Angle 6 and angle 11? Huh? No. It's good that you're confused. Let me ask you this, Monica. You should be able to answer this. Angle 6. Well, there you go. Yeah, angle 6. What transversal is it on? It's on C. Depending on your perspective, it's on C or it's on B, right? Depending on which way you look at it. Angle 11. Which transversal is it on? A or D. Read that note again under there. Exactly. It's not an angle pair. There is no angle relationship here. They're not on the same transversal. That's literally what you're going to write. No angle relationship. Oh, spelling words wrong now. You see it? I heard an O. No, I ain't bothered yet. Isaiah. Angle 4 and angle 13. Look at angle 4 and angle 13, man. Say it again. Yes, this is another no angle relationship problem. They are not on the same transversal. You can't sit there and compare those two angles. Colton, angle 4 and angle 9. A little bit loud, I can't hear you. Angle 4 and angle 9, Colton. You gonna give me something else, or you still thinking? A little louder. Alternate interior. Thank you, sir. Don't call the man stupid. alternate anterior. Alright, so those are angle relationships. Y'all did alright on that. On the back, we're going to take it to a little bit further. So on the front, these lines are not parallel, they're just running in the same direction. On the back, when you have two lines running parallel to each other and you got a transversal cutting through, if that's the case, if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So the corresponding angles you just identified to me would be congruent if the lines are parallel. The alternate interior angles would be congruent. The alternate exterior angles would be congruent. And each pair of consecutive interior angles would be supplementary. Reese, supplementary meaning what? You got 100 on the thing on Friday, Reese. What's supplementary mean? Equals 180. So the only ones that would equal up to 180 would be the consecutive interior angles, or the same side. Let's put same side there again to remind ourselves. Everything else is going to be congruent. Also, your linear pair. This is extra stuff down here. This is stuff we already know. The recall stuff. This is from last week. Vertical angles are always congruent. Y'all should know that. And then a linear pair is always supplementary. That's 180 as well. So you can see linear pairs on here. And you can see vertical angles as well. Alright. Example 2. Given the measure of angle 1 as 65 degrees, find the measure of each missing angle. Give your reasoning. The most important part on this is for y'all to give me reasoning for these. The angles are easy to find. I want to know that you know the angle relationships based on what they give you. The thing that they give me is 65 degrees. They give me one angle. That's all I need to find all the other ones. Because these lines are parallel, these angles will have relationships that will help you find all of them. New thing I need to tell you about too. The reason I know these lines are parallel, they didn't tell me up top here, but they did indicate it. There's an extra set of arrows on this line right here. This extra set of arrows on these lines are indicating that these two lines are parallel to each other. They'll either indicate it like that, or at the bottom, like they'll do here, they'll tell it to you. At the bottom here, they told us L and M are parallel to each other, or they'll indicate it on the actual lines like they did up here. Either way, you'll see it. Alright, then from there, the measure of angle 2 equals, before we even figure out the value of measure of angle 2, let's talk about a relationship between angle 1 and angle 2. Angle 1 and angle 2, what is their relationship? Anybody know? Vincent, go ahead. This is the old one. Supplementary, give me something better though. The angle pair relationship. I agree, they are supplementary. Nasir, go ahead. Oh. Yeah, they're adjacent too. So if they're adjacent and supplementary, what's their angle relationship? Linear pair. They're a linear pair. That's the part you want to know right there. If they're a linear pair, like y'all said, y'all know they're adjacent and they're supplementary. If that's the case, you should be able to easily find angle 2. Vincent, what's the value of angle 2? 115. Put that on your figure because we're going to walk through this figure too. Next one, measure of angle 3. Dior, this for you. Before we do angle 3, Dior, let's compare angle 3 to angle 1. Angle 1 and angle 3. Dior, give me their relationship. No. Look at them. This is the old one too. Angle 1 and angle 3. We're doing all of them now, including the ones we learned today. We're going to come back. Vertical angles. Remind you know what you know about vertical angles. They equal the same thing, or they're congruent, right? So obviously angle 3 is what? 65 degrees. Measure angle 4. Which one do I want to compare this to? I'll compare this to angle 2. I'm coming back to you, Dior, because I believe in you. Angle 2 and angle 4. What is their relationship? Angle 2 and angle 4. Look at it on your diagram. They vertical angles. If they vertical, Dior, what's the measure of angle 4? $115. Alright, so that takes care of our top 4 angles. We're moving down to the bottom 4. Let me do this comparison. We're doing angle 5 next year. So for angle 5, let's compare that to angle 3. Angle 3 and angle 5. Irvin, what's the relationship between angle 3 and angle 5? Yeah. A little louder, man. Don't be scared. It sounds like you said the right thing. Say it louder, though. 3 and 5, they on the inside or the outside? Huh? Interior. Okay. Alternate interior. What's up? Yeah, you could. It's more than one relationship I could connect that to. I'm doing these on purpose so I can make sure I touch all of them. Yeah, I could do angle 1 and 5. It'll be the same thing, but you have to tell me a different relationship. I'm mixing so I get all of them. I don't want to use the same ones over and over. But yeah, you can connect however you want to. As long as you connect a relationship and then be able to tell me the angle. What's the measure of that angle, Irvin? Angle 5. If they alternate interior, then they're 65 degrees. So on number E, not number E, letter E, I'm gonna use this relationship. I want to know angle 2 and angle 6. You can pick any ones you want. I'm just making sure I touch all of them though. Zuli, I ain't talked to you today yet. Angle 2 and angle 6. What's the relationship between those two? 2 and 6. A little louder. Corresponding, good. Corresponding angles are what? Corresponding angles are what? So what's the value of angle 6? Why you look scared? Yes, 115. Angle 7, what did I compare that with? Oh, okay. Reese, angle 1 and angle 7 for F. What's the relationship between angle 1 and angle 7?
Your phone has no signal, so I can't help you with that at the moment.
What you said? Alternate what? Alternate exterior. All right. What should you know about alternate exterior angles, Reese? No, that's gonna help you find angle 7, man. What should you know about alternate exterior angles that's gonna help you find angle 7? Thank you. So what's angle 7? Oh my God, Reese. So that's angle 7, last one, angle 8. I'm comparing that to angle 5. Who's a good person for this? So angle 8 I'm going to compare with angle 5. Faith, what's the relationship between angle 5 and angle 8? No. Good. Linear pair. At Faith, just for your knowledge, consecutive would be 4 and 5 or 3 and 6. Linear pairs when they one in, one out, and they sit adjacent and they form a straight line. But they both add up to 180 though. What's angle 8? 115. Huh? I hope not. We'll find out. I hope it's still recording. If it ain't, I'll do it next period. Oh, it's counting? Alright. Alright, so all that's just leading us to this point. Anytime we do notes, it's usually going to lead us here to the point where we got to solve equations. And that's where we at now. Hey. If L is parallel to M, find the value of each of the missing variables or variables. Identify the relationship. Even on your practice and your homework, I want you to do the same way I'm doing these. We're going to identify the relationship first. If you don't identify your relationships on your homework, I'm going to mark your problems wrong. Even if you sit there and set it up right and solve right. I want to know that you know the angle relationships. That's the most important part to me. Then after that, you can solve for X. Number 3, Mike. I'm going to mark the two angles that they gave me. They gave me 58 degrees on this angle. This angle right here, they gave me 5x minus 2. Before we even try to set up the solve for this, Mike, I just want to know the relationship between those two angles. Thank you, Earl. I ain't even call you today, man. My bad. Good look. Corresponding. If they're corresponding, then that means they're what, Earl? Up at the top. No, the top of your notes. They're congruent. I keep saying that because I want y'all to understand which ones are equal and which ones aren't. If they're congruent, then they're equal. If they're equal, then that is what it is. You should just be able to simply write an equation. Earlier, you know the equation? Thank you. 5x minus 2 equals 58. If you can set this up correctly, it should be easy for y'all to solve these. Most of y'all going to have trouble because y'all going to set them up wrong. Solve for x. I'm not doing that for you. That's too easy. Solve for x.
Minus 2, plus 2, plus 2. You get 6. 5 times 6. Yeah, 5 divided by 6. 12. Yeah, you got to divide 5 and 6.
So y'all should have the value of x. I'm moving on. I'm not doing these for y'all. Y'all be waiting on me to solve equations. Stop that. Solve for x. You should have this in your notes. Did you solve this yet, Connor? What you looking at me for? Alright. This should be in your notes. Number 4. Moving on. Number 4, they give you two angles here. Got angle relationships. 1. What's the relationship between these two angles that I just marked? Oh, on this one too, I need y'all to see this because I don't want y'all to confuse this. So, and we do this in situations where we can't fit an expression inside on the actual angle. 7x minus 1, they drew an arrow to the angle that they were talking about. It's that one in here, right here. It's not out here. It's in here. They drew an arrow to it. We do that a lot too, so I need y'all to understand that if we draw an arrow to the where the angle is supposed to be at or where the expression is supposed to be at, you gotta understand that it's right there. So that being said, Juan, what's the relationship between these two angles? We'll come back to you, Juan. Nick. Alternate interior. So these are alternate interior. What equation you gonna write to solve? You whispering, but okay. Yeah. Alternate interior angles are congruent, so you should know you can set that equal to each other. Solve for x, that should be simple. Yeah. Number 5. Well, y'all solved yet? Yeah, y'all should have. Shh. We almost there. Be quiet. Don't mess my video up with all that stupid talking. Beyonce. Number 5. They gave us these two angles right here. I just marked them for you too, just so you can see them. What is their angle relationship? That's what you said? Alright. Alternate exterior. What should you know about alternate exterior angles, Beyonce? I can't hear you. You whispering. A little louder. I don't even know what she's saying out there. Thank you. Jesus. Yeah, they congruent. 8x minus 77 equals 3x plus 38. Now I don't want y'all to get in the mind frame of thinking everything is going to be congruent. You should know it. Everything isn't. Just the case for these three. Alright, y'all should have value of x on that one. Moving on. This is the main one I want to get to because, you got to write an equation to solve for x, and then you got to go back and solve for y. We've done this on other problems. We haven't done this on a parallel line transversal problem. But last week we did this on one where y'all had angles where y'all had to do that. Y'all had to solve for x, then go back and solve for y. It's not a hard situation. I just got to keep showing it to you so you know how to. If you want to know a question that you'll be tested on, it'll be one like this, where you have to probably solve for multiple variables. We want to know if y'all know multiple angle relationships in one. So looking at this one, they give me two expressions for x and they only give me one for y. I need to go for the x first. But I still want y'all to tell me angle relationships and how to solve. Ryan. Ryan, what's the angle relationship on this one? To solve for x between these two angles. Alternate interior. Since it's alternate interior, I should know that those are what? Those two angles. Yeah, I'm still asking you. I've been asking this question the whole time. Yeah, they're the same. They're congruent. So you set them equal to each other. 8x minus 31 equals 6x plus 3. And solve that for x. We need to get x first. I'm going to let y'all solve for x. Y'all just tell me what it is. Well, actually, I know what it is. What's up? X equals what? 70? Make sure y'all solve the equation now. Y'all should be waiting on me to solve no equation. But you should get x equals 17 if you did it correctly. Once you get that, that's the value of x. You still need to find the value of y. But, and y'all need to listen, because like I said, this is a problem y'all going to keep seeing. And I'm getting tired of helping y'all on it. Pay attention. They give you the value of x. Well, you found the value of x. To find y, you need something else to write with this y expression. They only gave you one expression on here with y. But now that you know x, you can plug back in and find this angle and this angle. They're both going to be the same because they're congruent. If you set them equal to each other, they're going to be the same. Now, you can plug back into both. I know y'all been doing that since we started this school year, but I need y'all to understand now that you don't have to plug back into both of these expressions. You can plug into one and you're going to get the same answer for each one. So I always pick my easier expression to plug back into. Like if stuff is congruent. Like for example, I would do the 6x plus 3. So this one got 8x minus 31. I don't want to deal with them minus 31. I'm going to just do 6x plus 3. So that's the one I'm going to plug back in for and find the value of that angle. So I'm going to say 6 times 17 plus 3. That's going to give you 105, it should. 102 plus 3, yeah. Get 105 degrees there. And up here, this angle will be 105 too. If you don't believe it, plug it back in. You'll get 105 up there too. So those two angles are 105 degrees. Reason I need that is because now I got something I can use, or an angle I can use with this expression 5y plus 35. I just need to know the angle relationship so I write it correctly. So I'm going to go here. The 5y plus 35 and this angle. I'm going to compare these two. What's the relationship between those two angles right there? Just a minor? Okay. Minor say consecutive interior angles. That is correct. What should you know about consecutive interior angles, Amani? Say it again. They are supplementary. This is the one that switches on you. When you have consecutive interior angles, now you're thinking about supplementary. So instead of setting these equal to each other, Amani, what should my equation be? That's a plus 35. It just looked like divided by. Sorry. Just the way it got printed. Five y plus 35 plus 105 equals 180. Yeah. You could and just set that equal. That's if you want to. That's fine. I made them write out the supplementary equation. But if you can see it that way, I'm fine with you. You can do that as well. I just like them to write out supplementary equations. Equaling 180. Alright, so hey, just so you understand too, we just looked at it this way as consecutive, but you could have looked at it this way too. If you looked at it this way with this 105 over here in this angle, you would have had a linear pair, which is also supplementary. And you would still set them equal to 180 the same way we did this. You just need to understand that these relationships are similar just depending on how you look at angles. Consecutive here it would have been a linear pair. They both result in supplementary relationship. And then you solve for y. Y'all should have did that. What is y1? Probably is. What is the value of y? No, it gotta be more than 1. 8. Huh. Oh, okay, yeah. I see it now. 1/4. Alright, yeah. That's the notes.